this is what we'll be going through for today. Let's make that a presentation. All right, so like we said, I am a facilitator alongside Chidinma. Moving on, so what do we want to build today? Right, two major things. All right, so we're going to be building a light tracking robot and an obstacle avoiding robot. But before that, you need to understand what robotics is, what Arduino is, and what all these things are, right? So think of it as something that it's a process. By the end of the process, you should be able to build these robots. But during the process, you get to know what robotics is, get to know what Arduino microcontrollers are, what sensors and motors do, and all of that. So that's great. So this is our schedule. These are learning objectives. Just touch on that. You'll also be able to use Tinkercad at the end of this workshop. Okay, so let me put this here. So what is Arduino? What is Arduino? I'd like to ask a question once again. How many of us have come across an Arduino kit before, an Arduino board? Feel free to unmute yourself to answer any of my questions or use the chat.
Joseph, can I say something, please?
Yeah.
I'm sorry. With the
All
Google
right.
Slides, we need permission.
Sorry?
The slides.
You
I
need
shared the
permission to
slide.
what?
Could you make the slide public so anyone with the link can access it?
Okay, how do I do that?
If you go over to the slide and you do a share, it's if under it says restricted, and then you can switch it to. Actually, I think I can do it. I guess I have access.
Okay.
Anyone with the link. So yeah.
All right, so have you done it now?
Yeah, I think so. It seems like I had
All
access
right.
to it. Okay.
Oh, that's perfect. That's perfect. All right, so does anyone here seen or okay, I see Alex and Sasha said we didn't get ours. Sorry about that. But don't worry, you're in for a great time regardless. So have you come across an Arduino board before? Right, so think of it as a brain of a robot, right? So your brain dictates what you do, how you do it, when you do it, how well you do it, right? So a robot doesn't just do stuff, it doesn't just move in a direction. You tell it what to do, and the microcontroller does that for you, right? That's the powerhouse. So I have some information here. It says it's an open source electronics platform based microcontrollers, right? Arduino is a company that builds this, right? So says it makes it simple to read, sensor, and control outputs, right? So you can see here on the next slide a breakdown of the board, right? So we see we have some pins. All these things may not make sense to you yet, but as we continue through the workshop, you get hands-on experiences that will help you understand better. All right, that's great. So just a quick check. Are we all hearing me, please?
Can
And
hear
is my
you. It's a
screen?
little soft, but I don't know if you can increase your or maybe move your microphone closer to your
All right,
mouth.
is it better now?
Yes.
How is it now? Oh,
It,
perfect. All right, that's great. So that's on Arduino microcontrollers. So think of this, like I said, like the brain of the robot. So now let's go to what a robot is. What is a robot? You know, a lot of times when we talk about robots, everybody thinks of robots that looks like human beings, right? Humanoid robots. But that's not true. That's just a type of robots. There are several robots that don't even have eyes. They're just a robotic arm, but they pass as a robot. Some robots look like cars. Some robots look like uh different things, right? Different things. So here we see that a robot is a machine that can sense. That's where we get the word sensors, right? It can sense, it can think, and it can act, right? Just to put it in simple words, right? So it operates automatically and is programmable. It can perform various tasks like we'll be seeing today, and it consists of sensors. Think of those as the eyes and the ears of the robots, just the same way you can see stuff and then react or plan to react accordingly. Next, we have the controllers. That's like the brain. What I said earlier, the Arduino. Uh, the actuators, think of those as muscles to do work. All right, so what is robotics? Robots are great things, but the field of science and engineering that designs, builds, and programs different types of robots is what is called robotics, right? So that's where you also see things like artificial intelligence and what have you. And the beautiful thing about robotics now is that uh, it's finding application in various spheres of of science, right? So we see it in medicine, in education, in space, in industries, etc. All right, so let's move forward to sensors. So I said previously that sensors could be thought of as eyes and ears, right? So you see the environment, there's a change in the environment that's called a stimuli or stimulus for short, for plural, right? So the sensor sees that. For instance, if you walk into a dark room and someone turns on the light, you can't sense that with your ears, you sense that with your eyes, right? So similarly, sensors have what they sense. So for instance, you can see the gas sensor here. You can see the ultrasonic sensor. We're going to be using this today, right? You can see the flame sensor. You can see the soil moisture sensor. You can see several sensors here. So they sense the changes in environment, then they pass it as electrical signals, which is useful for our brain. In this case, our brain is the Arduino board, right? And then you can do a process, you can perform a task with the Arduino board based off the signals sent by the sensors. And then you can have an output or communicate something, right? So that is what a sensor is. A sensor takes the changes in the environment and converts that to electrical signals that the Arduino board can work with. All right, so what is an actuator? Would it be fun if all you could do was to observe the environment and not influence it? That would not be fun, right? So you see that an actuator helps you to achieve that if you are a robot, right? For human beings, for instance, we have hands, we have legs, and we can interact with the environment using our hands, our legs, and what have you. So for robots, we see DC motors. If you look closely, let me zoom in here. If you look closely, there's a motor here. This is a wheel. It's not a circular thing that's the motor. It's this cylindrical block, right? Or cuboidal block. So we have the stepper motors, we have the servo motors, the buzzers, the brushless DC motors, the LEDs. We're going to be working with the DC motors here and the LEDs today, right? That's exciting. So how does Arduino and robotic link? You can see that, like I said previously, the sensors generate signals for the Arduino, and then the Arduino tells the actuators what to do. Very, very simple. The Arduino is the brain that dictates what is done, and uh, the actuators carry that out. All right, so I'm on slide 10. Just a quick check. Is Chidinma around? Chidinma is also a facilitator. Chidinma, are you here? All right, no
Yeah.
problem. So, oh, you're here. Hello,
I think I
Chidinma.
can now.
Sorry, what did you say?
Can you hear me?
Yeah, that's great. You're welcome.
Okay. Share my slides now, or you control it from there, or
Okay, whichever is easy for you.
I think
You
I
could,
should share.
all right, no problem. So you can continue from slide 11.
Okay, can you all see my screen?
Yes, we could see it.
Yes.
Okay. Okay, we are going to talk about the Arduino IDE overview, and from there we'll do project later on. So the Arduino IDE is basically an environment where you write your code for your robot. It's where you ensure that your code is properly written without errors. And this IDE is what helps you communicate with your Arduino board. So the Arduino IDE, we have different parts, or like say sections. We have the menu bar, we have the toolbar. The toolbar is where most tools used in debugging, running your code, or verifying if your code is correct, and also choosing your board, the particular board you're using. If it's an Arduino Uno, an Arduino Nano, basically there are different types of Arduino board or different categories per se. Then we have the side panel, which contains your previously written code in files and folders, your library section, and then where you can install libraries and where you can install extensions. Then we have the output console. This is where you see whether you have errors, or this is where you see that your code has run successfully. While the code editor is where you actually type in your code itself. I think these are just the key parts of an Arduino IDE. So next, we are going to, oh no, no, no. Okay. Um,
You have to use the backspace.
this does not work.
Use the backspace to take you back a page.
Okay, I'm coming.
Or I could assist with sharing my screen. If that's great.
Okay, you can see my screen alright.
Yes, that's great.
Okay. We'll now talk about the part of an Arduino program and basic concept of an Arduino program. So any Arduino program is called a sketch. Basically, if you're starting to code newly on an Arduino IDE, you would actually see that it's usually saved as a sketch, and that's what it's called. So an Arduino program is basically divided into three. It has three categories: the structure, the values, and the functions. The structure consists of how your code is being written, where you have, in this little example here, the code snippet here, you have the void setup, void loop, and then where you initialize your variables. And then this structure also shows how the code is written based on logic. Now we also have values. These values are your variables and constants, what you're assigning to each Arduino pin, and whatever sensors you're assigning to your Arduino, and everything you're linking to it. The values you give to each component, especially when you're prototyping and coding. So we have the functions. These functions state what your code does. It actually gives attributes to each part of your component which you're using to build your robot or to build a device. So the structure consists of two main functions, the setup function and the loop function. Now, the setup function runs only once. It's where you define the logic of your code. It's where you tell us, okay, this code is for this robot, and this robot has to function this way. For example, if you have to use a sonar sensor in a robot, you need to tell us, okay, this sonar sensor, is it an input device? What is it going to be doing? That is where you give the particular logic, how your code is going to run, and it runs only once. The loop function is where your code is repeatedly running. It actually then defines the logic of your code. It shows, okay, this is what this robot is doing, and this robot should continue this function until this given command is stated. I'll give an example. Let's say you're building a weather station, and then your weather station has a temperature and humidity sensor. Now, in your void setup, you have to state that your temperature and humidity sensor is an input device that takes in signals of the environment. While in your void loop, you need to state that this sensor should give out values of what is detecting from the environment, and you should state how continuously it gives up this value. That's why the loop repeats to conform to the logic of your code. Did everybody get that? Please confirm that
Yes.
you can.
Yes, I got that.
So there are specific functions. These specific functions are quite unique to the Arduino IDE because when it comes to programming with other IDEs like VS Code and all, we use functions that are restricted to each programming language. I forgot to say, Arduino programming is based on C or C++, right? Yeah, C or C++. I'll put it that way because both are kind of similar. So when I talked about Arduino specific functions being just unique to the Arduino platform, I mean that when you're programming in other languages, there are functions relating to that language, which can actually be interchangeable. Yeah. Take for example, there are functions you can use in C++, and they actually be similar to be used in Java, right? So now when it comes to Arduino, these functions are actually kind of different and actually easier to implement. So we talk about the pin mode function. When you're assigning values to each Arduino pin, whether it's a digital pin or an analog pin, you use the pin mode function. This pin mode function tells the Arduino microcontroller that, okay, oh, this is being assigned to this pin. Now, the digital write function, with the word digital, you could see that we're talking about digital signals. So this digital write function detects or tells us that this pin that is being assigned is a digital pin and it should receive digital signals. We know there are two types of signals, analog and digital signals, right? So this digital write tells us the digital value of the pin. Normally, in Arduino programming, we use two digital values, high or low. Take for example, if it's an LED you're working with, if the LED is on, you say it's high. If it's off, it's low. That's what I mean. Then we have the digital read function. This reads the digital value of that pin in particular, whether it's high or it's low, and then continues on in the code. Then, for every code, you expected that you should get an output because you're definitely not coding for you to just read different programming functions, syntax, or whatever it is. So you need an output, just like you have a monitor that gives you an output of what your device is being programmed with, right? So now, when you don't have an output device or maybe an output component like an LCD screen, you can check out what your code is saying or what you've run in your program using the serial monitor. Now, when you use the serial monitor gives you this output. It's actually in the Arduino IDE. You then use two functions. You then use serial print in, right? The serial print in will now tell you, okay, this is what is being shown. I'll give an example using the temperature and the weather station. Yes. So when you're building a weather station, it's expected that the output from all the sensors used and the actuators used on that device should give temperature and humidity of your environment. Now, what the serial monitor then shows you based on your code would be the temperature and humidity of the environment where you have placed your weather station. Then finally, we have the delay. The delay is actually used to bring in some kind of pause during execution of code or execution of actions based on your code. I'll give an example. Let's say you're blinking an LED or you're blinking an LED and you want your LED to keep on blinking for a specific amount of time. You know that these are electronic devices and then you need to apply safety when it comes to operating them because maybe if they run out of voltage or something, they can actually burn out when there's excessive current given to it, right? So you need to put in some time in between when the LED is going to blink so that it does not burn out. And then also the time you're giving in between the LED to blink is for it to actually resonate with whatever you're building. It is blinking to signify that okay, there's smoke here or there is fire here or anything, depending on what you are building. It should actually be in the number of seconds or microseconds that you want the LED to blink. So this is where the delay function is used. So we can't talk about an Arduino or embedded systems or robotics components without having an idea of the basic electric circuit. Now, you need to know about the basic electric circuit because they are fundamentals that help you to build a circuit, especially when you're prototyping. Okay, for just to be sure, prototyping is basically building a device from scratch at the initial stages, simulating and all of that. So a basic circuit is a path through which electricity or current flows. And in a basic circuit, there's usually a path. Current flows from positive to negative. That's actually something like universally known. And then what actually makes a circuit work? A circuit works when it's a closed loop, its direction is correct, and then the polarity is defined. What do I mean by a closed loop? A closed loop, a closed loop is a path that goes from positive down to negative. It's properly connected and ensure that there's a ground. When there's a ground, then that loop is closed. When there's no ground, the loop becomes a short circuit. And a short circuit is very dangerous because it can send in a high amount of voltage that is not needed for that component and then makes the component to burn out. So a ground is basically what takes out the electrons that are not needed when current is being passed. It's just what makes your circuit to be balanced. That's why the ground is important. So the current direction, like I said initially, current flows from positive side to negative side. And then your polarity being defined means that there are some components that when you're connecting them on your breadboard or when you're using them to integrate them in a robot or anything, you have to like ensure it's placed in the proper direction because of the way current flows. Like in the slide, you can see where I mentioned an LED. An LED has a cathode and an anode. Like you can see here, the longer leg is a cathode, while the shorter leg is an anode, right? So you need to ensure that your anode is connected to the ground, which is the negative part of your battery or your power source, while the cathode is connected to the positive component, the positive side of your battery or your resistor, whatever you're using to connect it to power. So this is for LEDs. Other components have the way they work. Why some components like the buzzer does not really have a direction. You can connect it anyhow you want it to, and it will work that way. So also, we cannot continue or start off to build anything or prototype anything without knowing how breadboard works, right? So a breadboard is basically a temporary circuit. It's just like what you can use to connect circuits temporarily for a robot or whatever you're building. It's using prototyping. So normally in a breadboard, horizontal rows connect to the same component. It means that if I don't know, can you see my arrow? Can you see the cursor?
Yes, yes, I can.
So assuming I'm connecting an LED here, so that once I've put in a pin or an LED here, the current flows the same along the same line. While for the power bus, current flows vertically, right? So I did talk about different parts of a breadboard. Now we have the power rails. They are just three basic parts: the power rails, the horizontal rails, and then the center gap. Now this center gap demarcates the two parts of the breadboard, right? It just enables you to have a space to connect different components depending on the size of the breadboard, right? You need to know what you're building, and when you know what you're building, you know the size of breadboard to get. So this demarcation just gives that. And then the demarcation is also used to ensure that when you're connecting components like switch registers or let me say timers, you can actually connect on both sides or the two parts to accommodate some other components. I will talk about that soon. So the power rails is where you connect, ensure that there's power or well, let's say yeah. So it's where you ensure there is power in your circuit. Remember I said the breadboard is more like a temporary circuit. So this is where you connect your positive power from the battery and then your negative. You're just more like making this a temporary circuit for other components to come in. Now I'll use these two images to show you correct connections and wrong connections on a breadboard. Now, like I said initially, on this power rail, current flows horizontally, like on the same line this way, while for this one, it flows downward. It means that whenever I connect on this line, everything connects to that same component on this line. If you're meaning to connect an LED here, you cannot put in any wire at this area. So also, like I said initially, this center gap is basically used for timers or any microchip that you want to use or a microcontroller and just the chip itself. If you want to integrate that, then that's fine. So this is the correct way to make connections on your breadboard. Then for wrong ways, if you're connecting the positive to the negative, you get a short circuit, and it can cause improper voltage running across the circuit and can cause a burnout, or your microcontroller board can get fried, depending. So you don't also connect this way. It must be this way, straight up. I think that is all for that. So we talk about simulating circuits on Tinkercad. Okay, for simulating helps you to have a preview of what you're building, to eliminate mistakes, and to know the capacity of components you're supposed to use to build a robot, a product, a device. It also helps you to define the components you're supposed to use for each product or for each device. Or let me say, today that we're going to read really, but if you want to start out, you need to like simulate and know where each wire is supposed to go to, where each connection should go, what component you should use. So now, one of the platforms using simulating circuits is Tinkercad. It's actually one that is used for beginners, but there are other platforms like Pro and the rest of them. But we'll be using this one today. So I'll just be briefly explaining the two circuits and their code, and then we'll have a breakout session from there. I think that's okay, right?
Yes, just let me know how you want me to set out the breakout room, and I will start setting up.
Okay. So we'll be simulating two basic circuits, an LED and an LDR, and another one would be an LED and a button. So for the LED and LDR, we are simulating this because we are building a light tracking robot. And this LDR is a photoresistor. I think I'll have to explain some of the components for those that that may not be conversant with the components. So this LDR is a photoresistor. It just tracks light. It, okay, yeah. Can you can you hear me?
Okay, hey, do you want me to split into the breakout room, or you want to do this after this presentation?
After I'm done with this presentation, I want to explain the circuits and the two circuits and then the code. Then we then go into
Okay.
the breakout. Okay, so this is an LED. This is an LDR. I've explained what an LDR is. An LED is more like a little bulb, a light emitting diode. This is a resistor. This resistor limits the flow of current to this LED. Why? Because there's a maximum amount of current that the LED is supposed to take in. So you need a resistor to ensure that so much current or voltage does not go into the LED to avoid getting the LED burned, right? So these colored wires are what we use in connecting. So this basic circuit is just to signify that light is coming to this LDR, this photoresistor. So whenever there is light being sensed by this photoresistor, the LED is going to blink. So that's what the code is basically talking about. So now, for the part of the code, I would just like to give a recap. Then we then go to the breakout session. For this beginning part of the code, this is where you initialize your variables. Remember, I talked about structure, values, and functions being part of an Arduino program. Then this void setup is where you tell us the logic behind your code. You tell us what pin is being assigned to your Arduino board or to your LED. And then you tell us if that LED pin is an output pin for this now. Serial.begin. Serial.begin, we are using the serial monitor. So basically define what the serial monitor, the baud rate for the serial monitor. This is where serial.begin comes in. Now void loop now defines the logic of your code properly. It tells us the LDR value, the range for the LDR value. That's why you see LDR value greater than 600, whereby it tells us, okay, if the light rays for this LDR is exceeding 600, that is the amount of light rays, then the LED should blink. If not, the LED shouldn't come on. So that's all for this. While this is just a circuit to show that once you press a button, your LED comes in. The code works similarly. Yeah, that's all for now.